Hello, my name is Maciej Krosta, and I would like to welcome you to my webinar about event-driven HMI programming, when we will get to know about the HMI, what it is, what are the events, and we will make an example application utilizing said events. So let's start with what is an HMI. HMI is short for Human-Machine Interface. Basically, it allows the program to communicate with the user in a simple way through either displaying the information on the screen, but also allowing the user to input some data. So when it comes to the outputs, it can, for example, display the results of an inspection. So if the object is correct, we may have a large visible control that says that the object has passed. And conversely, we can have a large control saying that the object has failed. However, not only the results of the inspection can be displayed, we can also inform the user about errors, be it programming errors in the program, the application itself, or hardware errors. For example, if the camera disconnects, or the device loses communication with some other governing device through the network. This way, the program does not have to be overseen by another application. The user will be informed immediately that something is not correct. But as I mentioned before, the HMI also allows the user to input data. For example, it may be used to specify the exact tolerance for measuring holes, or other things depending on the object that is being inspected. Using HMI to define parameters and tolerances is preferable to having a different version of the program with modified parameters in code. The program is more flexible and will be easier to install on another machine when there is a need to expand. As we can see here, I have put an example of a control that can inform about the object status, an example of an error, and that simple control that allows the user to control the tolerance in millimeters. However, how to read an input from the HMI? There is the standard way, the explicit way, when in a certain part of the program, the control is read. So, in other words, the state of the control does not matter until it is read in the program. Of course, this means that each and every iteration of the program will have to check whether the control has changed its value. So it may also clutter the program a bit. However, there is also another way to read a state of the control, and it is with an event. An event is named like that because it happens immediately after something has happened to the control, where this something can be many different things depending on the type of control. For example, here we have a button. If it is clicked, it may start a button clicked event, and inside this event we may have a simple filter that executes whatever we want to do when the button is clicked. Now I will show you a simple application made in Adaptive Vision Studio. This application simulates a production environment. Let me run it now. As we can see, with each image we have a few elements to inspect, and what we are doing is basically measuring the diameter of each and every hole and comparing it with the template. So each hole can have only some tolerance that it is correct. We can control the speed of the simulated production line. So it can be fast, slow, or we can stop it altogether. With the when the setting is stopped, we can zoom in and analyze it a bit closer. However, it is important to note that this program is running synchronously with the images. That means that when there is no incoming image, the program will wait for it. In other words, the program will not execute, will be stopped when there is no image. Which means that if I were to change the tolerance to 0, it will not be an immediate effect. And by the way, let's see what are the effects of tolerance 0. We can see that every hole is marked with red, and the whole object is also marked with red. If I set it to 2, as it was, and run the inspection, the elements are green again, and the whole inspection has a pass result. Also, there is allowed defective holes settings. When we set it to 0 and run the inspection, let me actually change the input folder to the defective elements. As we can see, this element has been bent, so it is totally incorrect. None of the holes are in the expected position, so every hole has failed in this element, and we can see that this element is marked with red. The other ones are marked with green. However, the overall result is fail. But also, we can have an element like this, which lacks only one hole. However, since we do not allow any defective holes, it is also marked as a not OK object. However, if we were to increase the tolerance for the defective holes to 1, and then we stumble upon this kind of object, we will see that it is marked with green, even though there is no hole, because that's what our settings tell. However, there is one problem with the program you may have noticed. The tolerance and the production speed are possible to modify by anyone, no matter whether that person is authorized or not. That may not be really desirable in the production environment. So how can we avoid a situation like this? How can we put the control behind a password? For that, we have a special control in Aptiv in the password protection section, the password panel. So let me add it now. And it behaves like a panel, so everything inside of it will be password protected. So let's drag the configuration controls into the panel. We can actually dock it to the top. And we can dock the panel to the top as well. What is also important to remember about the password panel is that you may want to place a logout button inside, so that it is possible to log out and make it impossible for unauthorized users to access it, even though we have logged previously. So let's change the name to something more appealing, log out. And let's dock it to fill. However, when we run the program now, when we try to log, we cannot log because there are no credential files. So to add a credential file, we can use tools, edit HMI user credential file. And this is where we basically create user accounts. So let's add an admin account with the highest access level. And let's put some password. In this case, it's a very simple password, but it can be anything we desire. And let's save this file, preferably into the program folder. Let's call it credentials. Now we need to find the panel here and specify the path to the credentials file in here. Credentials AV user. If we try to run the program now, we will be able to log in. And now the critical controls are protected with a password. Unauthorized people will not be able to mess with them. We can also log out. What is important to notice here, on the other hand, is that if we stop the application, we can still log out. And we can still log in. Because the password panel does not interact with the main loop of the program. It is the login and logging in and logging off is basically an event. When this button is clicked, there is a behind the scenes event that tells the password panel to hide its context. And also, if the proper credentials are entered and the button is clicked, it tells the password panel to show its contents. This is independent from the main loop of the program. So as you can see, even though there are no explicit HMI events, this control basically utilizes them, but they are hidden from the user. So let's add something more to the program. We may have noticed that the lines are quite thin and sometimes hardly visible. We can correct it with changing the line width. The line width can be changed in the properties of the View2D box that displays it. In here, we could change it to 10, for example, and run the program now. However, we may want to be able to change them live when the program is running. So to do that, let me add a track bar control. And this track bar, actually we can dock it to the top. We'll go from 0 here, 0, to 30. But we need to connect it to the line width input, but it is not visible here. However, we can also, not every input port and output port is visible by default. We can edit the visibility of the ports for the control here. And at the end, almost at the end, we have line width. So now we just need to pass the value from the track bar to inline width. To do this, we can create a new step, change line width. Inside of it will be a formula. Let's call it out width. And in the meantime, we will connect this output port of the control to the formula. And let's finish the formula. Out width will equal to in value. And we can connect it like this. When we run the program now, the track bar is set to 0, and the lines are basically too thin to be visible. Let's stop it. We can see that the line is here, but it is very thin. Let's change it. However, it is not updated until a new iteration has passed. But after that has passed, we can see that the line width has been changed. But we don't really like the fact that we need to wait for the iteration to finish and for another one to continue. How can we make it so that it is updated immediately? with an explicit HMI event. To create an event, we can, for example, go to the properties of the control, go to the events section category, and we are interested in the value change event. So let's add a new event here. We'll call it line width changed. Now we have another step in the project explorer. So basically in that step, we want to do what we are doing here. So we can just place this filter here. And now when we log in, stop the production, we can see that the line width is changing live. Because each time the value has been changed, it is an event is called and executed. However, the trackbar has its advantages, but we don't know the exact value, at least the numeric value. We would have to count the ticks here, but it is not really convenient. We can use a nice feature of the HMI. So let's add a label here. And let's knock it to the top. And labels can have are able to utilize the feature for auto value source. We can select which control will be the source of the data. As we can see, it is 0 now. And when we run the program, the label is updated according to the trackbar. Also, we can format the text. We can type anything we want, line width set to colon, and we need to input % for the value. And as we can see, it has even it's been updated in the HMI designer itself, and it will be updating live. However, now that you will notice that since the lines are very thin at the beginning, it is not what we want. So we can change the trackbar starting value to, let's say, 5. It has been also updated. So now we can, without any problems, modify the line width, and it will be by default 5. So the line width issue has been solved, but what about the colors? Let's say we want to change the pass and fail colors. First of all, we will need to show the appropriate input ports of the View2D box, because the pass color and fail color are here, as we can see, but we want to be able to change them from the program. So edit the visibility in pass color, in fail color. And now we need a control that will give us the color picker. Let's call it pass color, and another color picker, fail color. And as we've changed line width, we'll create a new step, this time from this, change colors. Inside of it, we will have a formula, pass color. So pass color will be connected to the value out of this color picker. And fail color will be connected with this one. So let's finish the formula. In pass, out fail color, in fail. And we can now proceed. However, the problem is that we need to first add the step to the program. So let's add it here. And now another problem has occurred. The color picker by default is set to black. So let's change the default value here. Green, red. When we change the colors now, we will notice the difference very soon. But since it is not based on any events, the colors will not be updated until we run another iteration. However, the how to make an event is basically the same as before. We just need to go to the event category, value change, add a new event, color changed. And we want to just execute the new step here. Also, we want the fail color to call the same event. And now, even though we stop the application, when we change the color to, for example, red, everything is red now. Purple, yellow. But the color is displayed here, but we don't really know exactly what the color looks like. We can do it. We can do a simple trick. Let's add a simple panel. And we want to have another input in back color. Now let's copy this panel, paste it again, add the same input as before, and modify this filter to also pass the color here and there. Now we have a simple indicator what the color is currently set to. But there is one final problem with the program. This panel takes a lot of space, and it is not really necessary most of the time, because the most important information about the object is at the top. So how can we do it? Since this view to the box is set to fill, and it is in the same container as this here side panel, which is set to right, if we were to make this panel invisible, the view to the box would fill the whole available space. So let's add a new button. This time it will be a toggle button. We can fill it here. Toggle button has a nice feature that on and off text will be different. So when it is off, we want to notify the user that clicking it will show the settings, and off, hide settings. And this button will be connected to the new event, value change, add new, settings button changed. And in this event, we will basically need one thing: formula, visible, out value, connected. So out visible is connected to the out value of the button. And this, in turn, will be connected to the visibility of the whole side panel. But first, we need to make it available here. However, when we run the program now, the button assumes that the settings are hidden, and only the second click does what we expect it to do. That's because the button is by default set to false, and we want it to be set to true. And now, in our little program, when we want to hide the settings, they are immediately hidden, and the image is centered and has more space to be displayed. And everything is possible to do even when the application is stopped. So that was a simple example of an HMI-driven program. Now I would like to show a bit more advanced example, rather to show what we can achieve with the HMI. This is a demonstration program when we have an image. When we double-click the image, we create a point. When we double-click it again, we create another point. And a segment is drawn between the points, and we have the profile of the image along this segment. However, if we click near the point and drag it, we can update the segment, and when we release the button, the profile is updated again. Notice that in the main loop of the program, there's basically nothing. We only load the image, put it into a global parameter, and loop the program. The parameter here is the most important thing, because this is what is used by every event. For example, if we double-click the event for the double-click, we either add the current click location to the or update. This event, image mouse double-click, is a dedicated event. As we can see, we have input parameters related to the event. As we can see here, we use almost all the events for the view to debug, and in location is the the cursor location. However, it is in the coordinates of the image. So here we add the point to the global parameter of point array, marked points. In mouse down, we check if if the cursor is near a point. If it is near, we mark this point as grabbed. When we move the mouse, we just continually update the position of the grabbed point and update the segment as well. And when we release the mouse, we nullify the grabbed index, so no point is being grabbed. However, you may ask, but wouldn't it be possible to have the profile be updating live when we dragged it? It would be possible. In fact, what we need to do is to add the filter for updating profile to the event for the mouse movement. Now, when we create a segment and drag it, we can see that the profile is updating live. However, there is a slight problem here. It may be not visible here on the recording, but the dragged point lags behind the cursor a bit. That is because updating the profile updates this whole control. It also needs some calculations to be done, and this takes time. HMI events should be as fast as possible and as lightweight as possible. And this event for mouse movement is basically run every time the mouse changes its position over the image. That's why it may considerably slow down the program. That's why I did not make it so that the profile is updated when the mouse moves. And the point now is sticking close to the cursor. And this whole program is basically run by the HMI events. We utilize many global parameters to achieve what we want, but the main loop of the program is very simple and not cluttered at all. That concludes my presentation about the HMI events. I hope you have learned something new. Thank you for watching my presentation. I want to wish you a good day.